Okay, we move on to question 3. Question 3 says determine the area under the standard normal curve that lies between. So now we are given two known values, and we want to find the area that lies between them. So for A, the area that lies between negative 2.04 and 2.04. So that I have shaded over here in the color black. Okay, so I've shaded that interval in the color black. So I made a sketch of it and shaded that region. Okay, and mathematical notation, that is P of negative 2.04 is less than Z less than 0.04. Now, if we want to use the standard normal table to be able to do this, then we have to rewrite our probability. Remember, the standard normal table gives us the area to the left, right? The one that we are using in this class gives us the area to the left. There are several other types out there, but the one we are using in this class gives us the area to the left. So what we need to do is, if we can find the area to the left of the larger portion, and also find area to the left of the smaller portion, and subtract the smaller area from the larger area, then we are going to get the area of the area between the two numbers, the two z-scores. So writing that mathematically, that means probability of z being less than 2.04 minus probability of z being less than z less than negative 2.04. So probability that z is less than positive 2.04, we find that in the table that has the positive z values, and that gives us 0.9793. And for probability of z less than, that is to the left of negative 2.04, from the standard normal table, that gives us 0.0207. And the difference between these two probabilities is negative 0.9586. 0.9586. So that is for example A. Now 3B wants us to find the probability between negative 0.55 and 0. Okay, negative 0.55 and 0. So remember, the z-score or the z-values, the values of the standard normal table, are negative and positive values, right? The range of negative and positive values. And the value in the middle is 0, which is the mean or the median. So in this case, mathematically, that is probability of negative 0.55 is less than z less than 0. Okay, and the region is shaded in the picture. Now, we have to also rewrite like we did before. That is probability of z less than 0 minus probability of z less than negative 0.55. Okay, so for the first area, when z less than 0, it means that what is the area to the left of the number 0? And what is 0? 0 is the mean or the median, which divides the curve into two equal parts. So on one part, the area will be 0.5, on the other part 0.5. So P of z less than 0 is 0.5. Then the P of z less than negative 0.55, we find that from the standard normal table. Okay, and that gives us the value 0.2912 from the standard normal table. And then doing the subtraction, then the area between 0.055 and 0 is 0.2088. All right. And using the calculator step for the first example, area between negative 2.04 and 2.04, that will be normal CDF. Now, the smallest value in the interval is negative 2.04. And the largest value, or the upper bound, is 2.04. And then the mean is 0, the standard deviation is 1. So that resolves to be 9.9 0.9586 approximately to 4 decimal places. Then B, area between negative 0.55 and 0. So normal CDF, smallest value in the interval is negative 0.55. Then the largest value is 0, followed by the mean 0 and the standard deviation 1. Approximately, the result is 0.2088. Okay. Okay, so we move on to question 4 and 5. Now, these two questions follow the same approach. This time around, what you are given the area and you are being asked to find the z-score. Okay, so given the area, how do you find the z-score? So it's more like the reverse of what we did in the first two questions. Okay, so with that said, number 4 says find the z-score such that the area under the standard normal curve to its left is 0.2. Okay, now to be able to sketch this, you need to remember how the standard distribution or the standard normal distribution looks like. So that is a sketch of it, and you have the mean in the middle, which is 0, right? So if the mean is in the middle, exactly in the middle, it means that on the left, the area to the left of 0 is 0.5 and to the right is 0.5. So if we are told that the area to the left of the z-score that we are looking for is 0.5, then it means that it's 0.2. Then it means 0.2 is going to be the area that I've shaded, and that is what we are looking for. That z-score will be to the left of 0. Okay, so that is why I have z equals the question mark. So to write that mathematically, that means p of z is less or equal to the number we don't know of, and that number and that probability is equal to 0.2. So how do we find that from the standard normal table? So this time around, we are going to start off from the area because that is what we are given. So we look in the table and see where the area 0.2 occurs. Okay. Now, when you look through the table, you may not see exactly 0.2, but you may see a value close to that. Okay. Now, you realize that we have 0.2005 and also 0.1977. By looking at this, the closest is 0.2005. So we focus on that and then match along to find the z-score that corresponds with this value. So you move up along that this value 0.2005 falls in the column 0.04 and along the row negative 0.8. So it means that the z-score that has the area to its left being 0.2 is negative 0.84. Okay, so that gives you the result for question 4. Now to question 5. We are being asked to find the z-score such that the area under the standard normal curve to its right, the area under the standard normal curve to its right is 0.35. Okay, so this is slightly different from the first one. Now we are giving the area to its right. But remember, the standard normal table gives us the areas to the left of whatever z-score you are looking at. So we need to do something slightly here, a slight change here. If we know the area to the right of the z-score we are looking for, then we can tell the area to the left. And that will be 1 minus the area to the right, which is, in this case, 0.65. Okay. So with the number 0.65, we look in the standard normal table for the area 0.65. We don't see 0.65 exactly, but we see that the area closest to it, which is 0.6517, right, falls or corresponds with the z-score 0.39. Okay, so it means that the result for number 5 is 0.39. So that is how you use the standard normal table to do that. Now, to use the TI-84, to look for it. Then the z will be the inv norm, 0.2. Okay, so now we have the information on the area and we want to find the z-score. So the calculator function that we use is known as inv norm. And how do you find that? You kind of follow the same way that you used to find the normal CDF. So you do second distribute, and then the third option is inv norm. So you enter inv norm, and the first input of this function is the area to the left of whatever z-score you are looking at. So the area to the left for question 4 is 0.2, followed by the mean, which is 0, and then the standard deviation 1. So the calculator gives us our result, and to 2 decimal places, that is negative 0.84. So for question 4. Now question 5, we still do inv norm, but remember the information we are given is area to the right. But the calculator only takes the input where the area that you consider is area to the left. So we don't put 0.35 in there, but then 0.65. So 0.65 followed by the mean, followed by 1, which is the standard deviation. And to 2 decimal places, our result is 0.39. Okay, so to question 6 and 7, we look at something which is similar to what we have already seen, but it's just a way that z-scores are written. Okay, so it says in problem 6 and 7, find the value of z alpha, z sub alpha. Now, when you see the notation that way, so z sub alpha, what it means is that you are looking for the z-score, okay, which is a positive value, where the area to the right of that value is alpha. Okay, so that is what I've drawn, and then I've shaded the region where alpha falls. So that is z sub alpha. So if we are looking for z sub 0.05, what that means is we want the z-score where the area to the right of that z-score is 0.05. So the z-score where the area to its right is 0.05. So if we are using the standard normal table and we are given this information, what that means is, you remember this standard normal table, you can only use the area to the left to look for whatever z-score you want. So to find the area to the left of the z-score we are looking for is then 0.95, which is 1 minus 0.05. So with 0.95 as our area to the left, then we look in the table and see the z-score that corresponds with area of 0.95. So we don't see 0.95 exactly in the table, but then we see two values that are exactly, that have the same distance away from 0.95. And those two values are 9.9495 and 0.9505. So what do? Do we pick one and leave the other? No. So we rather take the average. Okay, so if 9.9495 falls corresponds to the z-score 1.64 and the other one 1.65, then the average of these two z-scores will be 1.645. Okay, so this is the case where you have two values or two areas having this being the same distance away from the z-score. So the z-score for z sub 0.05 is 1.645. 1.645. All right. Then the second one, z sub 0.025. What that means is we want to find a z-score where the area to its right is 0.025. So to be able to do that with the standard normal table, we look for the area to the left, which is 0.975. Okay, and we look for that value 0.975 from the table. So with this area in the table, wow, this one is perfect. We see exactly 0.9750 in the table, and that corresponds to 1.96. So our z-score now is 1.96. 1.96. All right, so this is how you do it using the standard normal table. What if we are using the TR84 function to do it? So remember, you are given the area and then you want to find the z-score. So similar to what we did in questions 4 and 5 with 6, inv norm, then the area to the left, okay, then the mean, then the standard deviation, and that gives us 1.645. For the second one as well, inv norm, area to the left, 9.975, the mean, the standard deviation, and that gives us 1.96.